Hello friends, so today we are going to do part 1 from the year 2024, and in this part 1 we are going to solve 12 questions, and all these 12 questions are from the mains. So the first question, it states that an electric charge 10⁻⁻6 microcoulomb is placed at origin of xy coordinate system. 2 points P and Q are situated at square root of 3 meter and square root of 6 0 meter respectively. The potential difference between the points P and Q will be. So this question states that we have a electric charge and that charge is given at the origin. So let us draw a coordinate system. So we have a x-axis and y-axis, and the charge is located at the origin. So this is a charge, and there are 2 points P and Q, and P is situated at square root of 3 as well as square root of 3. So let us suppose this is our square root of 3, and on the y-axis we also have square root of 3. So somewhere here, let us suppose this is point P, and Q point is located at square root of 6 meter respectively. So let us suppose this is square root of 6, and this point will be our Q point. And at P point, we say we are having a potential difference of Vp, and at Q point we are having a potential difference of Vq. So we have to find out the potential difference. So in order to find out the potential difference, first of all, because charge Q is, suppose this is charge Q, value 10⁻⁻6 microcoulomb. So we have to find out the potential because of this charge at point P. And let us suppose the distance is our Rp. And similarly, we are going to find out the potential of this charge Q at our point Q. And let us suppose this distance is our Rq. The standard formula for the potential, we already know that potential at a distance r from a point charge potential at a distance r from a point charge, and that if we represented as V will be equal to Q upon R, where K is 1/4 pi epsilon naught. And Q charge we already know, we need to find out this value of R. And we have 2 points P and Q. So let's find out distance of origin, because charge Q is located at origin from point P as well as from point Q. Distance from origin to P and Q. So first of all, let's find out our Rp, that is distance of point P, which will be our, because origin is our 0, so we can say square root of 3 plus square root of 3 and its square and its square root, which will be coming as 3 plus 3, and that will be square root of 6. Similarly, we can find out our R of Q, which will be equal to our square root of 6 plus 0 square and its square root, which will be also coming as square root of 6. So from here we can say that our Rp is equal to our Rq, and let us suppose they are equal to R because they are root 6. Therefore, the potential difference which is our V will be equal to Vp minus Vq, and we can just K, this will be Q upon Rp minus KQ upon RQ. Here Rp and RQ are equal, therefore these both terms cancel out and we get the potential difference is equal to 0. So option number 3 is the correct one. Option 3 is correct. Next question. So we are given a thin metallic ring wire having a cross-sectional area of 10⁻⁻⁴ meter square is used to make a ring of radius 30 cm. A positive charge of 2 pi coulomb is uniformly distributed over the ring, while another positive charge of 30 picocoulomb is kept at the center of the ring. The tension in the ring is, provided that ring does not get deformed, neglect the influence of gravity. So in this case, we are given a thin metallic wire. Suppose this is a thin metallic wire and it has a positive charge uniformly distributed, whose value is given as 2 pi. And at the center, another positive charge is kept, that is our 30 picocoulomb. So obviously there will be force of repulsion between the two. Okay. And so force of repulsion, or we can say there will be outward electrostatic pressure which causes tension in the ring, and this repulsive force will try to expand the ring. Okay. But it is a metallic ring, so it has a limited space for the expansion, or in ideal case it should not be expanding, but the force will be always present. Okay. So first of all, let's find out the force, and or rather we can say we are going to use a small segment and we are going to find out the force per unit length. So we can say that central charge repels the positively charged ring uniformly. Okay, so there will be a uniform electrostatic pressure because of this central charge. We can say the central charge Q repels the positive charged ring uniformly. And from here we can say that there is outward electrostatic pressure. There is outward electrostatic pressure which causes tension in the ring. Causes tension in the ring. So first of all, let's find out the force per unit length on the ring due to central charge. So you can say force per unit length on the ring due to central charge. Due to central charge, and that force is represented by small f. So we can say this value of small f will be equal to our k. Suppose central charge is given as q upon radius is our r square multiplied by, or we can say q multiplied by lambda. Okay, because lambda is the charge intensity of the ring. So the lambda is equal to charge density, sorry, not intensity. So we can say this is charge density of ring, and we can easily find out value of lambda. Lambda will be equal to, this comes as total charge on the ring, that is q divided by 2 pi r, okay, and r is the radius. So this 30 pico is our small q and this 2 pi is our capital Q. So we substitute value of capital Q, we get this as 2 pi and this comes as 2 pi r, which will be equal to 1 upon r. And for F is the force per unit length. So we substitute value of lambda, we get our F is equal to K, and this comes as Q upon R cube. Okay, so this is the force per unit length. And now this force is going to, we can say this force will be generating a electrostatic pressure, or it will try to expand the ring. So you can say this force tries to expand the ring, okay. And because of this the tension will be generated, and this tension will try to balance the force F. Okay. So you can say, so the tension, suppose that is capital T in the ring, must balance this. And we can say that the relation between tension and the force per unit length, or relation between the force F and the tension T, and because it is said that the shape of the ring is not deformed, so it means it is under symmetric radial outward force. Therefore, from there we can write that our F will be equal to T upon R, or we can say our tension T is equal to F multiplied by R, which gives F, we found out, is our K Q upon R cube multiplied by R. Here R goes by this square, so we get get T as will be equal to KQ upon R square. And we already know the values, so we substitute them. We get tension T is equal to value of K is 9 into 10 raised to power 9. K is our 30 picofarad, 10 raised to power minus 12, and radius is our 0.3 meters, which comes as whole square. And the tension will be coming as 3 newtons. Therefore, the tension will be our 3 newtons. Next question. It states that the electric potential at the surface of an atomic nucleus Z is equal to 50 of radius 9 into 10 raised to power minus 15 meter is. So this is directly based on the formula, and we know that the potential is given as KQ upon R. And here we only need to find out our Q. Z is given to us, Z multiplied by the charge on one electron, that will be our Q. So this comes as, we can write that our V will be equal to K Z multiplied by E divided by R. So we substitute the values. We get V is equal to 9 into 10 raised to power 9. Z is our 50. Charge on one electron is 1.6 into 10 raised to power minus 19. And radius is given to us, that is 9 into 10 raised to power minus 15. Okay. And this gives us that value of voltage, that is potential, will be equal to 8 into 10 raised to power 6 volts. So this was quite simple, directly based on the formula. Next question. It states that two charges of minus 4 microcoulomb and plus 4 microcoulomb are placed at origin A at points A, that is 1, 0, 4, and B 2, minus 1 and 5 meter, located in the electric field E, and it is given as 0.20 I unit vector. The magnitude of the torque acting on the dipole is 8 square root of alpha into 10 to the power minus 5 Newton meter, where the value of alpha is. So we are given that we have a charge, and so electric field is toward x-axis. Okay, so we can just draw approximate figure for that. And we have this our x-axis, this is y, and we are given that this will be our z-axis, and we are given the point A is at 1, 0 and 4. And other point is given as 2, minus 5 and 0. So first is our A is our 1, and Y is our 0, and Z is given as 4. So Z is given as 4. So this is somewhere, let us suppose this is about 4, and the point will be somewhere here. Let us, this point is A, and the other point is given as our B, and here it states that X is about 2 and Y is minus 1. Okay, so y is -1. So let us suppose this is our -1 and z is equal to 5. Okay, so z will be 5. Okay, it will be in 3D. So I think much better is that we can draw it in a simplistic way, other way also. Okay, because we are going to get the point. This is a z axis and z is given as 5, so this is a 5 somewhere here, and so if we this way and 5 towards the third. Okay, so best, so we can just plot it. So let me draw. So we have electric field, that is our E in x direction, and we have a charge that will be, let us suppose, something like this. This is our A and this will be our B, and A is given as minus of Q and B is given as plus of Q. Okay. And we need to find out the torque. Okay, so we know that our torque is equal to our dipole moment multiplied by electric field. And first of all, we are going to find out the dipole moment, and we know that our torque is equal to dipole moment and cross our electric field, and our dipole moment P is equal to charge and distance, and we can easily find out our distance, that is distance this d. Okay, so let us start with our point P, and no, sorry, not point P, but our dipole moment. So you can say our dipole moment is our P is equal to charge and our d vector, which is the distance between the two, that is plus q and minus q, and we can say our this d displacement vector will be equal to, we have their positions as 2, -1 and 5, and A is having 1, 0 and 4. Therefore, our displacement vector will be equal to 2 -1 and I unit vector plus -1 -0 j unit vector, and finally we have plus, and we have this as 5 -4 k unit vector. So this gives us I minus j and plus k. So this is our displacement vector, and our dipole moment P, charge we already know is our 4 microcoulomb, 4 into 10 to the power -6, and this comes as our I minus j and plus k. Now we can easily find out our torque, and we are given that torque is equal to P cross E, and P we already know, P is our 4 into 10 raised to the power minus 6 I minus J plus K, and this is a cross of our 20I unit vector. And so we can just take that our torque will be equal to, this will be our 20 into, I think it is only volt per centimeter. Okay. And we get this as our 8 square root of alpha. Okay. So we get this as 8 and into 10 raised to the power minus 5, and this is I we get this as our I cross I will be 0, and this will be our J, and will be coming as positive and plus K. We are interested in magnitude, so we can say our torque magnitude will be equal to 8 into 10 raised to the power minus 5, and this comes as square root of 1 square plus 1 square, and that will be 8 into 10 raised to the power minus 5 into square root of 2. And the given equation is our 8 given equation is our 8 square root of alpha. It is our 8 square root of alpha into 10 raised to the power minus 5. So this gives us that the value of alpha is equal to square root of 2. And Newton meter? Yes. Next question. It states that two charges 5q and minus q are situated at point 3a0 and minus 5a0 respectively. The electric flux through a sphere of radius 4a having a center at the origin is. So in this case we are going to find out the electric flux, and one of the straightforward approach of finding electric flux is using the Gauss law. And the Gauss law that states that our flux will be equal to charge enclosed divided by epsilon naught. And here it is given that the radius of the sphere is 4a. So let us draw the radius of having a, so this is our radius, this is suppose our x-axis, and this is center origin O, and radius is our 4a. So let me draw, this is our radius, that is our r is equal to 4 times a. So we are given 2 points, one point is 3, 0, so that will be somewhere here. So this is 3a, 0, and here charge is our 5q. Other point is our minus 5a, 0. So this is our somewhere here. This is our charge minus 2q, and it is minus 5a, 0. So it means only one charge is lying inside the sphere whose flux we are going to find out. Therefore we can say that charge plus 5q lies inside the sphere. Lies inside the sphere. Therefore, we can say that the charge enclosed will be equal to plus 5q, and the flux will be equal to our charge enclosed divided by epsilon naught, which gives us 5q divided by epsilon naught. Okay, so option number 2 is the correct one. Option 2 is correct. Next question. It states that an electron is moving under influence of electric field of a uniformly charged infinite plane sheet S having a surface charge density plus sigma. The electron at t is equal to 0 is at a distance of 1 meter from S and has a speed of 1 meter per second. The maximum value of sigma if the electron strikes S at time t is equal to 1 second is alpha m epsilon naught E coulomb per meter square. The value of alpha is. So here we are given the infinite plane sheet. So we can just draw an approximate figure for that. So we are having an infinite plane sheet, and it is given as charge density of plus sigma, and we have electron at t is equal to at a distance of 1 meter. Okay, so suppose we are having an electron which is suppose somewhere here, and this distance is 1 meter. And it says that electron strikes the sheet S. So this is sheet S in 1 second. It means time taken by the electron to travel this 1 meter is our 1 second. So sheet is having a positive charge density, and electron is negative, so there will be force of attraction between them. So we can say that force of attraction between the electron and the sheet. Force of attraction between electron and sheet, that will be given as, we can say, F will be force, and that is equal to our minus E times the electric field. And electric field of the sheet having a charge density of plus sigma is given as sigma upon 2 epsilon naught. So we can write this as minus E, and this comes as sigma upon 2 epsilon naught. And force will be resulting into a acceleration, that is our mass into A will be equal to minus E sigma upon 2 epsilon naught. So this gives us that our acceleration A will be equal to charge sigma upon charge oblique mass sigma upon 2 epsilon naught. So this is the acceleration of the electron. Now we can use here acceleration is negative because it is moving towards the sheet opposite side. Okay. And we are interested in finding out the maximum value of sigma. Acceleration we already know, distance we know, time we know. We can simply use the equation of kinematics. So we can say equation of kinematics, which tells that S is equal to ut plus half at square. And here S is our -1 meter, time is our 1 second, and u initial velocity is given to us, that at this particular moment u is our 1 meter per second. Okay. And the time taken to travel is also our 1 second. So we substitute the values, we get S is our 1 and u is our 1, time is also 1, and acceleration we just found out is minus, and this comes as E upon m sigma upon 2 epsilon naught, and this comes as t square and 1 square. So we get from here, this will be 1, 1 plus 1 becomes 2, so therefore we can write this is 2 is equal to, and minus 2 rather, this will be minus 1 by 4. We have here E sigma upon m epsilon naught. Here minus and minus goes away, so we are interested in sigma, so sigma will be equal to our 8, and we have this m epsilon naught and divided by E sigma. Sorry, sigma we need to find out. Okay, and the given equation of our sigma. So given equation for sigma is given as alpha m epsilon naught upon E. So given equation for sigma is our alpha m epsilon naught upon E. So making 1:1 comparison, can clearly see our alpha is equal to 8. So value of alpha is our 8. Next question. We are given that an electric field is given by 6I plus 5J plus 3K Newton per coulomb. The electric flux through the surface area of 30I meter square lying in YZ plane is in SI unit. So we are given electric field at a point which is our 6I, okay, electric flux, and we need to find out the flux, and flux we know is our E dot A, where A is the area vector. So we can say that our electric flux phi will be equal to our E dot A, or we can say this will be our E magnitude of A and cos of theta. Theta is the angle between the two, and we can just substitute because the vector notations are given to us. So we can say our flux phi will be equal to E is given as 6I plus 5J plus 3K, and we have a dot 30I, and here dot product means same, so this will be giving us 60, 6 multiplied by 30, which will be coming as 180 Newton meter square per coulomb. So option number 3 is the correct one. Option 3 is correct. Next question. It states that the electrostatic potential due to electric dipole at a distance r varies as. So this literally asks the general formula for the electric dipole at a distance r, and here you can say the distance r is not mentioned whether it will be at equatorial line or it will be on the axial line. We have to find out the general formula for the electric potential due to electric dipole, and that is directly based on the formula that the potential that is dependent upon r as well as theta is equal to 1 upon 4 pi epsilon naught, and this comes as p cos of theta divided by r square. Here p is our dipole moment, which is our q, into p is our dipole moment, which is given as q times distance between the charges, and our theta is the angle between the dipole axis and position vector r. Theta is the angle between dipole axis and position vector r. Position vector r, and r is the distance. Okay, so from here we can clearly see that we have this is inversely proportional to 1 upon r square. So option number 2 is correct. Option 2 is correct, or we can just write it here also. V is proportional to 1 upon r square. Next question states that a charge of minus q and mass m moves in a circle of radius r around an infinitely long line charge of linear charge density plus lambda, then its time period is. So it states that a particle of charge minus q mass m moves in a circle of radius r around an infinite long charge of linear density. Okay. So let us suppose this is our infinitely long. Let me draw the circle first. It will be much more easier. So this is our circle on which the charge is moving, and this is our infinitely long line charge, and it's given as plus lambda, and the radius of this circle is given as small r, and charge rotating is our, suppose at any particular moment the position of the charge is, let us suppose this one, which is given as minus of q, and it is rotating in this direction. Suppose direction doesn't matter, it is rotating only, and there will be a force experienced by this rotating charge, which is minus q, and the infinitely long state conductor or line, which is having a plus lambda density. So basically it is having a positive charge. So there will be force of attraction, and this attractive force, we can say that force on the particle, or we can say attractive force, on the charged particle, on the charge minus q, we can write that our F is equal to q multiplied by E, where E is the electric field And the formula of electric field we already know, that electric field at a distance r with respect to the charge density lambda is equal to lambda upon 2 pi epsilon naught multiplied by r. So we substitute value of this electric field, we get this as q multiplied by lambda divided by 2 pi epsilon naught multiplied by r. And this is the centripetal force for the circular motion. You can say this is the centripetal force for circular motion. And centripetal force we also know is given by the formula, that is our F is equal to mv square upon r. So we can equate both expressions and we get this as q lambda upon 2 pi epsilon naught multiplied by r is equal to mv square divided by r. And here this r and r cancels out, and we can say that our mv square is equal to q lambda upon 2 pi epsilon naught. We need to find out the time period, so you can say time period if given as capital T, which will be equal to our 2 pi r divided by velocity v. And we need to find out time period. So we can just square both sides and sort it out. Okay, so here let me substitute m here. So we are just going to square the equation, which gives us t square is equal to 4 pi square r square upon v square. Now we can easily substitute value of v square. We get this as t square is equal to 4 pi square r square, and this comes as q lambda, and it goes in the numerator, which comes as 2 pi epsilon naught multiplied by m. And now we can just multiply them, which gives us that our 8 pi cube epsilon naught, and we have this m, and this is q times lambda. We need to find out the time period t. So now t is equal to 8 pi cube epsilon naught m q lambda and its square root. So this is our the time period. Next question. It states that two identical charge spheres are suspended by a string of equal length. The strings make an angle of 30 degrees with each other. When suspended in liquid of density 0.8 gram per centimeter cube, the angle remains the same. If the density of the material of the sphere is 1.6 gram per centimeter cube, the dielectric constant of the liquid is. So here we are given two cases. One is without the liquid and other one is with the liquid. And the condition is that angle should be same. Because they are identical charge, so there will be force of repulsion. So we can just draw an approximate figure for that. And suppose this is our mean position, and because the force of repulsion, let us suppose the charges are somewhere here. So the force F in the downward direction, we are going to have mg, here also mg, and there will be a tension T in the string. And let us suppose this angle is over theta, so this angle will be also for theta, and total angle is given as 30 degrees. So this entire angle is given to us as 30 degree. Now this is without the liquid. And so we can say the electrostatic force when this entire setup is in the air. So we can say that electrostatic force in air, let us call that as F air, and that will be equal to our 1 upon 4 pi epsilon naught, and this is about q square upon r square. Okay. And when it is dipped in liquid, we can say electrostatic force in the liquid, Okay, so this is with respect to air and this is with respect to liquid. Air, and this is our liquid, and we can call this as F liquid, and its dielectric constant is K. So we can say this will be equal to 1 upon 4 pi epsilon naught times K, and angle has to be same, so this will be q square upon r square. So we can easily write that our F liquid will be equal to F air and divided by K. Now, when the entire system is in air, the weight in the air, you can say that our weight in air, we call this as W air, and that will be equal to our mg. But the weight in liquid, we call this as W liquid, will be equal to mg minus the buoyant force, that is our FB. Okay, because there is a charge in the downward direction, we are going to have mg, and in the upward direction we are going to have the buoyant force in the liquid. So here FB is our buoyant force. And we already know, we can write this as our W liquid will be equal to, and with respect to their densities, we can write our mg, and this will be 1 minus, we got the density of the liquid divided by density of the our sphere, that is our S suppose, which is given to us as 1.6. So we can easily find out the density of liquid, its ratio, and we can say that density of liquid divided by density of sphere will be equal to over 0.8 and divided by 1.6, which gives us 1.2. Therefore, weight in the liquid will be equal to our mg, and this comes 1 minus 1 by 2, which will be equal to mg by 2, that is half of mg. So we got the weight in the liquid. Now we are given that the angle should be same. We are given that angle is same, and if angle remains same, so it means the ratio of the horizontal force to the vertical force is going to remain same, which means ratio of horizontal to vertical force it remains same. And therefore we can say our force in the air divided by mg will be equal to force in the liquid divided by weight in the liquid. Or for the sake of simplicity, let's write this as weight in air, because it will be same, weight in air. So therefore we substitute the value, and weight of, we can further write it as force on air divided by our mg is equal to weight in the liquid we know is our force, force in liquid is force on air divided by constant k. Weight in liquid is our half mg. So from here mg and air goes away. So this gives us that our 1 is equal to this 2 upon k. Therefore we get that value of k is equal to 2. And we can also solve this question in a little bit different way. We can divide the tension into two components, cos theta and sin theta, and then balance them, and same we can do inside the liquid also. Okay, that's another way, and we can just divide it, tension goes away, the forces we know, so we can just solve it, and this is a little bit different way to solve the same question. Next question, it states that two charges plus q and 3 plus 3q are separated by a distance r in air at a distance x from a charge q. The resultant electric field is 0. The value of x is. So here we are given that we have two charges. So let us suppose these are the two charges. This is point A and point B. Point A is having plus q and point B is having plus 3q. And it says that at a distance x from charge q, resultant electric field is 0. But the position of this q is not mentioned. So this point q can be within the line, within the point A and B, or it can be outside point A, or it can be outside point B. Okay, so we can say, but we can make an approximate guess that actually where this point B, this charge q will be placed, and that states the electric field should be equal to 0. And the charge is given as plus q, so there will be force of repulsion between all the charges. So if net resultant electric field is to be 0, the force of repulsion should be in the opposite side, and that is only possible if we have a charge that is of Q lying somewhere between A and B, because the electric field of one will be the opposite of other. Then we are going to get net electric field will be equal to 0. If it is lying somewhere here, so because of this Q it will be in this direction, and because of this 3Q it will be also in same direction, as well as it hold for true for here also, because of force of repulsion it will be in same direction. So somewhere in between the point A and B it should be lying, and this distance is given as x, and total distance is given as r. So we are going to have this will be our r minus x. And at point Q we are given that their resultant electric field is 0. So let us call this as point as O point. So you can say at point O we are only interested in magnitude, so you can say magnitude of electric field due to plus Q should be equal to electric field due to plus 3Q, and formula is quite straightforward, that is equal to KQ upon x square is equal to K 3Q divided by r minus x whole square. And this K, Q cancels out, therefore from here we get that our r minus x whole square is equal to our x square. And if we open it, x square is going to cancel out, and or we can just write it directly also. We can say that our r minus x, one second, I missed something, I missed 3. So r minus x is equal to square root of 3 times x. Okay, and from here also we can make an approximate guess, because if you open it, x square and x square is going to cancel out, so we are going to get only one solution of it. Okay, so it means point O will be only one, there can be 2 points. And from here we need to find out our x, so we can say that our r will be equal to x, we can take as common, so this comes as square root of 3 plus 1, which gives us that our x is equal to r upon 1 plus square root of 3. So option number 3 is the correct one. Option 3 is correct. Next question. It states that force between 2-point charges Q1 and Q2 placed in vacuum at r centimeter apart is F. Force between them when placed in a medium having a dielectric constant K 5 at r by 5 centimeter apart will be. So there is a change in medium, and we have to find out the force when the medium is changed. So in vacuum, you can say force in vacuum, that is given as F. So we can say our F will be equal to our K. Let me don't K, because dielectric constant is given as K 1 upon 4 pi epsilon naught, and this comes as Q1 Q2 upon r square. And now we have a dielectric medium, so you can say force in medium force in medium, let us suppose that is of F prime will be equal to, this comes as 1 upon 4 pi epsilon naught multiplied by dielectric constant, and rest of things are going to remain same. Sorry, distance is also changed. And we just open the bracket and we get this over F prime will be equal to 1 upon k, and this will be coming as 1 upon 4 pi epsilon naught q1 q2, this comes as r square and multiply by 25, and this particular is nothing but our F. So we can say this will be equal to, we have this as 25 upon k, value of k is given as 5, and multiply by force F, because this is our nothing but F. So 25 goes by 5, so we get our new force F prime will be equal to 5 times F. So option number 2 is correct. Next question. I think this is the last one. Yes. So this was part 1 from the year question 2024. Total question we did were 12. Okay, so there might be possibility that we will be able to cover all the questions of 2004, that will be mains as well as advanced, approximately into 3 parts, or might be 4th might be required. Okay, so this is the first part completing 12 questions, and all the 12 questions are from the only mains 2024. Thank you.